going. So we started this whole unit with just this thing called congruent shapes, right? We went through all these crazy shortcuts. Side, 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 angle, side, angle, side, angle, 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 side. And yesterday we talked about isosceles triangles and equilateral triangles. And today we're going to talk about right triangles. Are you scared of right triangles?
No.
Okay, it's nothing crazy. We're going to do one more congruent shortcut, but with right triangles. And before we can do anything with that, we have to discuss what you call different parts of a right triangle. The hypotenuse. Have you ever heard the word hypotenuse before? Okay, which one's the hypotenuse? The left one, the bottom one, or the right one? The right one. This guy right here. This is the hypotenuse. The hypotenuse. The other things are called legs. They're both called legs. So, if you were going to explain to somebody what the hypotenuse was, you would tell them it's the side opposite of the right angle. You have the right angle right here, and it's like it's pointing to the hypotenuse. Nope, nope, nope. All we already know is we need to know what a leg is and what a hypotenuse is. So, if we have a right triangle and we can see a hypotenuse and a leg, we can use the hypotenuse leg shortcut, HL. So what does the hypotenuse leg shortcut mean? It means one pair of congruent hypotenuses. Hypotenuse is hypotenuse. Did I spell that right? Yeah, hypotenuses. Hypotenuses, that's a weird word, right? But it's not as bad as hypoteni. Like you can't say funguses, it's fungi. So instead of hypotenuses, it's supposed to be hypoteni. So hypotenuse leg is one pair of congruent hypotenuses and one pair of congruent legs. This is a really good one. You have to do two things. One, is it a right triangle? Yes. Do I have an H and do I have an L? Yes. It has nothing to do with angles. Okay? For the HL shortcut, you don't need any angles, just an H and an L. Because if you try and use an angle, you would say side, 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 angle, angle. And what does that spell? That spells ASS. Remember, that doesn't prove anything. So the ASS shortcut does not work here. But the HL shortcut does work. One hypotenuse and one leg. Cool, right? Okay. So that's all I'm trying to teach you today. Now we're just going to practice that one concept. Are you ready? One yes. Can you use the hypotenuse leg shortcut to prove that those two triangles are congruent? Okay. What is marked? What is this mark? That's a leg, which is congruent to the other leg. The line in the middle is the hypotenuse, congruent to the other hypotenuse. What shortcut do I have? The hypotenuse leg shortcut. So I'm going to write my triangle congruence statement. Name the first triangle. IFG. So we started here went towards the right angle, and went away. So it went short, right, long. Do the same thing on the other triangle. Name it the same way. GHI. I said G, but I wanted to write H. Those two triangles are now congruent by the hypotenuse leg theorem. What can you say about FG and HI? What can you say about these two pieces? How do you know they are congruent? Because of CPCTC. Because corresponding parts of congruent triangles are congruent. Look, it says it right there. It says FG and HI are the same. CPCTC. Oh, I remember that, right? You did that yesterday? We did that Tuesday. Good job. Okay. Are these two triangles congruent?
No.
No. Is there anything marked? All we know is that they're right triangles. I know nothing else. Cool, right? No. Answer is no. Are these two triangles congruent?
Yes.
Yes. How do you know that?
They're
Mark. Okay. So what is this mark?
H.
Which is congruent to this H, because they are hypotenuses or hypotenae. Hippopotamus.
And the last one is L.
These are L's. So those two triangles are congruent by the HL shortcut. We must write a congruent statement. SRZ. Okay, that says right angle across the short side, across the hypotenuse. So I must start at the right angle. STZ. All right. What can you now say about angle R and angle T? They are congruent to each other. Cool, huh? What can you say about line SZ and line SZ? They're congruent to each other. So, could you prove those two triangles are congruent by the side, side, side theorem? What? We have a leg.
Yeah.
Is that SSS? Yeah, so you could have used SSS, but you didn't say that, so I didn't do it. Sucks for you. What else can you say about that triangle? You could say SAS because it said leg and leg were the same, angle and angle were the same, this side's the same of itself. SAS could have proved congruence. What else can you say about that triangle? We could talk about this triangle for months. I'm looking for one specific. No, it's not equilateral. Looking for one specific comment before we can proceed. Nope. So it said, based on the information you have, what else can you conclude? So you guys said the triangles are congruent, right? You got that. You understand that? You understand that this triangle and this triangle are the same. Okay? You said you used the HL theorem to do that, which is great. If you started over, you could have said that this line was the same as itself, and then you could have used the side, side, side to prove that those two triangles were congruent. Or you could have started over and said this line was congruent to itself, and you could have said side angle side would prove they were congruent. right? But no one said anything about the shape in general. It's a triangle, right? Well, describe it to me.
Same size.
Name the triangle. Give me a name for that triangle. Describe it. Here's an example. Baker. Male. Beautiful. Describe that triangle to me. Huh? I wonder what kind of triangle it is.
Isosceles.
Ah, well done. It's an isosceles triangle. Remember, the congruent marks point to the congruent angles. And we also said CP/CTC that these angles were the same. So it has congruent base angles. Look at how much stuff you can almost write. How many pages do you think you could write about that triangle?
Very little.
Very little? Let's go over all the stuff we talked about. You could use HL to prove they're congruent, right? You could use side angle side to prove they're congruent. You can use side 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 to prove they're congruent. You could say R and T are congruent because of CP/CTC. You could name that an isosceles triangle because it has two congruent legs and two congruent base angles. That's a lot of stuff. We could write pages for days, right? You might be prepared for that. Just saying. Okay, go back to what we're doing today. Can you say these two triangles are congruent by the HL theorem? Are they right triangles?
Yes.
Do they have an H?
Yes.
Do they have an L?
Yes.
Are they congruent? Write the statement. N M L. N M L. So you went long side, right angle, short side. SBR. Why are angle N and angle S congruent? CP/CTC. Because corresponding parts of congruent triangles are congruent. Are these triangles congruent? Yes. Okay, so the math application, right? That's the application of mathematics. It says, for what value of x and y are these triangles congruent by the HL theorem? So I'm asking you to force the H and force the L to be the same and give me the number or the x value that makes them the same. So which one is the hypotenuse over here? The 3y minus 3. This is my H. Where's my H over there? The y plus 12. This is my H. Which one's my leg on the left triangle? This is the leg. Where's the leg on the other triangle? The 3x. So if I'm going to use the hypotenuse leg theorem, I must force my h's to be the same. How do we do that in math? Make them equal to each other. So this h is 3y minus 3. This h is y plus 12. I'm going to force my h's to be together, the same, so I can force my triangles to be congruent. Help me solve that. Minus a y from both sides. 2y minus 3 equals 12. Add 3 to both sides. Y equals 15. Divide both sides by 2. So y is 7.5. If I plug y back in, that makes this side 19.5. If I plug y back in over here, it makes this side 19.5. That's really odd. They're the same number. Is that supposed to happen? Yes. So I have two hypotenusae that are 19.5 units long. I must figure out how long my leg is for the triangle. Set them equal to each other. 2x plus 3 is equal to 3x. Minus 2x from both sides. And x equals 3. So if I plug that 3 back in, 2 times 3 is 6, and 6 plus 3 is 9. 3 times 3 is 9. So have I forced those two triangles to be congruent by the HL shortcut? They have a pair of congruent H's, and they have a pair of congruent L's. They are the HL shortcut. All right, what about this guy? For what value of x and y are the triangles congruent by HL? How do we do it? Force them to be equal to each other. How do y'all want to start that one? Minus 2x from both sides. Get all the x's on the right. Move all the numbers to the left. The opposite of plus 1, minus 1. To get 4 by itself, or get x by itself, divide by 4. So x is 2. If I plug that back in here, 2 times 2 is 4. 4 plus 9 is 13. I plug that back in here, 6 times 2 is 12. 12 plus 1 is 13. Math across the bottom. What has to happen for my legs to be the same? You force them equal to each other. How do y'all want to do it? Okay, minus a y from both sides. That's a good idea. 1 equals 1y minus 3. Add 3 to both sides. Y equals 4. So I do 4 plus 1, and I get 5. 2 times 4 is 8, minus 3 is 5. That's weird, I got the same number. Please tell me, as much as you can, about that triangle. It's an isosceles triangle because this leg and this leg are the same length. What else do you know about that triangle? It's congruent. This triangle over here and this triangle over here are congruent to each other. So what can you say about this angle right here? Because it's an isosceles triangle. You could even use Pythagorean theorem to solve for the length of the line in the middle. Okay, changing gears a little bit. A little recovery. Multiple choice, A, B, or C. Which shortcut do you think proves these two triangles are congruent? Sure, that'd be great. SAS. Does that work for this? Yes. Which shortcut do you think proves these two triangles are congruent? A. S. A. The S. 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 shortcut. Side, angle, side. Angle, side, angle. S, S, S. A, S, A. You're good. Why is this one weird? There's no vertical angles. Okay.
SAS.
You have to first know which two triangles you're trying to prove. We have HJK, which is HJK. That's one triangle. The other one is LJI. The red triangle and the yellow triangle. Alright. On the yellow triangle, we have this side is congruent to this side. Right? And then on the yellow triangle, we have 2 marks here and 1 mark here. And on the red triangle, we have 2 marks here, 1 mark here. So what can you say about this length of the yellow triangle and this length of the red triangle? They're the same. So this line, sorry, that was bad. This line of the yellow triangle is a side that is the same as this line of the red triangle. So right now we have 2 sides that are the same. Can you say anything about this side down here and this side down here? No? Do you think they share an angle?
Yeah.
Which one?
Vertical.
Is this angle even formed by the red triangle?
Out.
So right now we have 2 pairs of congruent sides. What is the only answer choice that has 2 S's in it?
A and B.
A and B do, right? Did we say, are these the same? I wonder if they share an angle.
J, yeah.
They share this angle J.
Oh.
So it is SAS.
SAS.
Now, when you see this question on your test, it's going to ask you, what angle do they share?
Oh.
How do we do that?
Angle.
I went and looked at the statement and it said they both have an angle J. They share that angle. That was pretty hard, right? That was fun. Pretty. Hey, this looks familiar. Huh? Well, it's not in your notes. Wonder where I saw it. Are you sure? It's not on my notes. Wonder where it is. Huh. Well, Corey's got it on his paper. Oh, wow. I want to talk about it anyway. It says RT is perpendicular to SU and RU is congruent to RS. Why is statement number 1 true? given. Then, how do I know that RT is the same as RT? The reflexive property. And then they're already like, hey bro, you have congruent triangles. How do they know that? Or how are we supposed to know that? Not giving it. How do I know that's true? What shortcut could possibly prove that those two triangles are the same? Hypotenuse is
L.
the HL shortcut. Crazy, right? What was the, look at number 3, the proof right below that. What's your given statement? On the paper, on your paper, on your homework, what's your given statement? Where's your given statement? Does it say given information at the top? Does it say this? So you cannot do that proof. Scratch it out. It is mathematically impossible to prove number 3 because I do not give you any information. Scratch it out. Huh? No, not at all. Number 7. Where's that? How big is X? 17, because there we congruent by the HL shortcut. It says, for what value of X will they be congruent by the HL shortcut? So, if I want to use the HL shortcut, this 13 has to be congruent to what? This 4x plus 1. So I have to write that down. I want to make 13 equal 4x plus 1. How do I solve for x? Minus 1 from both sides. And then divide both sides by 4. So x equals 3. Now, if I want those two triangles to be congruent by the hypotenuse leg shortcut, what has to be true about the bottom pieces? They have to be equal. But it has x and y. I don't know how to do that. Help. Plug in the x. Take this x and plug it in. So this is really 6 plus y is equal to 24 minus 2y. I'm going to add 2 y's to both sides. Then I'm going to subtract 6 from both sides. Then I'm going to divide both sides by 3. I get 2 answers. X equals 3 and y equals 6. A lot of math going on there. Okay, the last part says you need to add 1 additional piece of information to prove these two triangles are congruent. So for number 12, what else do I need to know for those two triangles to be congruent by the HL shortcut? They're not right triangles? I have to put the little square. I have to say, hey bro, it's a right triangle. Now it's hypotenuse leg shortcut. Oh. What about number 14? What else do you need to know? The hypotenuses are equal, so you can just mark that. I need to know this. pretty tough, huh? You good? And then I'm all out of math. That's my last one. Whatever you have not done and is left is your homework tonight.